Good morning. So let us continue our lesson in planar geometry. This session probably let us focus a little bit on problem solving from your side. I left some problems unsolved from last time. I don't know if you have thought about them. We will come back to them, but let me start with very simple questions for warm up, and I want to solve them for me. Okay, so. Let me start from a very simple one. So assume that you have this quadrilateral, something like that, or you can consider them as two angles. And let me call these angles alpha and beta, and this angle, for example, gamma and theta. Yes? So I want you to prove it for me. So you see, when I was drawing this shape, I was not careful at all. Okay, I have to be careful that these are straight lines only. That's the only constraint. I want you to prove that alpha plus beta is always gamma plus theta. Okay, so it doesn't matter if I'm very careful about how to draw this. I want you to show for me that this is indeed the case. So when I draw something like that, alpha plus beta is always equal to gamma plus theta, independent of the details of my shape. Yes? Okay, successful? Yes. So what should I do, Sammy, for example?
The angles next to alpha and beta, you can define them as a circle and square. Yeah, and can you just draw the circle and square?
So I don't understand what you mean by circle and a square.
The angles next.
This one?
Yeah, here. You can draw.
Okay. I mean that you want to give it a name.
A new variable.
Okay, let me give it x and y, okay, if you don't mind.
X and y.
Okay, so let me give it a name, x, and then you want to give this one a name y.
Yes.
Yes.
And alpha plus x and y plus beta.
Alpha plus x is 180.
Yes.
You want to say this?
Yes.
And beta plus y is also 180.
Yes.
Then?
And together they're 360 degrees.
So together means adding them up, yes?
Yes.
So this becomes alpha plus x plus beta plus y equals to 360 degrees.
Yes. And inside
Just one moment. Sorry.
And gamma plus delta plus x plus y is also 360 degrees.
Yes, because that's a quadrilateral.
Yes.
And so it means that x plus theta plus y plus gamma is 360 degrees.
Yes.
And then it becomes very clear now, yes? Because this is 360 degrees, that's also 360 degrees, so they have to be equal. Yes? So this means that alpha plus x plus beta plus y is equal to x plus theta plus y plus gamma. And I hope that you agree this equality is independent of the details of my shape, yes? And this means that, okay, what can I cancel from both sides? This can be cancelled, this can be cancelled, so what is left is alpha plus beta is equal to theta plus gamma. Yes? That's a very easy problem. Yes. So, but discovering these generic relations are very nice because it is completely independent of the details of my shape. Any other suggestions?
I did the same.
Did the same, okay. But I was thinking a little bit differently. I don't want to start, that is the way that I have learned mathematics. I don't want to start everything from scratch, okay? So if I want to solve that, I would prefer myself to write it like it, to draw this line, yes? And then what happens, I will have alpha, which is an exterior angle to this triangle, yes? So alpha becomes this part plus that part, yes? I want you to understand, even if you 100% correct, but I want you to at least understand my method as well. So alpha is an exterior angle for this triangle. Is that clear for everyone? Yes? And then you know the theorem that alpha should be equal to the sum of two opposite interior angles. Opposite interior angles in this case are these two. So let me call this gamma 1, the first portion of gamma, and theta 1, the first portion of theta. So this becomes gamma 1 plus theta 1. Yes? And then, I hope that you understand what I'm going to do. What I'm going to do now?
Same thing.
for beta. Beta is exterior angle for this triangle. So I would write beta is equal to this portion. I don't know how should I. So let me just give them names instead rather than putting these arcs. So gamma 1 and gamma 2, and then theta 1 and theta 2. So definitely beta is gamma 2 plus theta 2. Yes? And then I am interested in alpha plus beta, so I add them up. But when I add alpha plus beta, I can choose in which order I can add. So gamma 1 plus gamma 2 is the same as gamma, and theta 1 plus theta 2 is the same as theta, yes? That's also an alternative. So it means that, of course, this is not something independent, as Samir mentioned, because if you remember the formula, the reason that this is true is because of these kinds of reasonings, yes? But I want you to train yourself not to start everything from scratch every time. Okay, let me give you another problem. These are very simple problems, but I want you to train yourself so that you can see the patterns quickly. But that was very good, thank you. Another problem, let us consider this. I have a triangle. Yes, A, B, and C. Let us assume angle B is greater than angle C. Yeah, in my picture. So angle B is greater than angle C. And then what I do, I draw the height or the altitude corresponding to this vertex A, and then I call it AH.
Wait.
Yes?
What are we written there with the greater and less signs?
No, this is the angle sign.
Oh, okay.
And even in LaTeX, if you use this, it generates this.
Yeah.
This is more common than putting that.
Yeah, it just looked like you're right. It's
Greater or less
than
no, that's not. So yeah, let me write it like this. Might be that's confusing. So let us stick to this symbol. So angle B is greater than angle C, and then I draw the angle bisector of interior angle A. So I just want to understand, I have this angle A, I divide it into two equal parts by this, say, if I can somehow motivate you that this is a good picture, and then it goes and intersects D here. Intersects BC at D here. Okay? Now, I am interested in this angle. Yes. I am interested in this angle, assuming that I can give you any angles of the triangle if you want to. So assume that I give you the angles of the triangle, the interior angles of the triangle, and I ask you to find the measure of that angle x. Answer this question. Do I really need to know all three angles? I just want you to discover it yourself. I don't want, because I can write the formula here for you and then ask you to prove it, but this in itself has a guide inside it. But I want you to discover it yourself. Is there any way? Assume that if you want, I can give you the measure of angle B, the measure of angle C, and even if you want, I can give you the measure of angle A. By the way, do I really need to give you the measure of angle A?
No.
No, because if I give you the measure of angle B and the measure of angle C, automatically the angle A is clear, yes? So, assume that I give you two of them, and I ask you to find x. I want you to discover it yourself. Okay, is the question clear? Assume that angle B is 60, for example, I don't know, angle C is 45 degrees, and I ask you what is this angle. But I don't want you to work with numbers, I want you to learn to work with algebra, yes? Yes?
Was B, H, and HD the same?
No, there is no guarantee. So even if you guess that they should be the same, you have to prove it for me. What I know this is a random scalene triangle. Scalene means that there is nothing particular about my triangle.
Okay.
So I have a scalene triangle, whatever it is, and then I draw this height and I draw the angle bisector for this internal angle A, interior angle A. And then I'm asking you to find it. If you think they have to be the same, you have to prove it. So that is also the nature of geometry. You have some guess. You need to motivate yourself. Is this guess correct or not? This is up to you. If I want to say that BH and HD are equal, I have to mention it myself in the problem. If I don't mention it, it is up to you if that is true to prove it. Is the logic clear? So you cannot rely onto the picture even if they are 100% correct, right? Or precise. Sorry. When you have your formula ready, please tell me. You want to say something, Rasmus?
I think I have a formula. There it is.
Yeah, just read your formula if that's correct. Or
Found that x should be equal to 90 minus c divided by 2.
So it means that you only need the smaller angle, yes?
Yeah. It almost feels like too simple or too easy.
No, it's not. It's not hard. It's not a hard problem. The reason that I mention it, I want you to have it somehow in your memory somewhere. If the angle between the height and the angle bisector as a relation, yes? That's not a formula in my head, but I think that's right. But if you can defend it if you want to. So what you say, you want to prove this for us, that angle x is equal to, as you said, 90 degrees minus angle C divided by 2. Is that right?
Mm-hmm.
Yes?
Yeah.
Okay, so now I want to hear from you. How do you say that?
Well, I said that the angle between the height and AC,
Height and AC.
AH and
So
AC.
this one you mean? Yes?
No, the angle that x is a half of. So the angle between the height line and the line AC.
Ah, okay. So from here to here you mean?
Yes. Called that.
All that what?
Gamma.
Gamma.
And then we could say that gamma should be equal to 90 minus c, since.
So let me just see that, because I want to correct you if that's wrong. So let's just tell me. So gamma is what?
Or no, long way. We say that gamma plus c plus 90 should be equal to 180 degrees.
Yes, because okay. So gamma plus c is 90.
Yeah.
Yes, because this is a right angle triangle, and these are acute angles, so the sum should be 90. So what you're saying is that gamma plus c is 90, and I agree with that. So gamma plus c is 90 degrees, yes?
Mm-hmm. And then just move c over to
And
get gamma is equals to.
Yes, so gamma is 90 minus c. And then?
And then we can say that x should be equal to gamma divided by 2.
No.
Wait.
Why should
Wait, what angles does D bisect?
No, you need to know. Okay, I told you that AD is the angle bisector of the angle A.
Oh.
Yes?
Okay.
Is
Okay,
that understand?
then-
So there is no reason. Might be my picture is a little
I
bit.
thought it was between the height and AC.
No. The interior angle A, AD is the bisector of that one. So I hope that you agree that this formula is not correct,
Yeah, no.
because it is based on that intuition.
Or,
Yes.
yeah, or I just had understood wrong word.
Okay, so I give you still time to think. Yes, Oscar?
Well, I think I have a method.
Do you have your formula that you can read it for me?
Well, no, I don't. I guess not. It's not a formula. If you're
No,
looking
I want you to continue until you have your formula. Yes, because we have to learn to finalize the problem. Yes?
Okay.
If you have a rough idea, crude idea, you have to actually cook it up. Yes?
Yes.
Yes, Sammy?
Well, I think the formula is x equals 180 minus h plus c in parentheses, and
What
plus,
is h then?
in parentheses 180 minus h minus
So
c.
let me again. So you want to tell me that x is equal to what? May you please repeat it?
In parentheses 180
180.
180 degrees,
Yes.
minus in parentheses h plus c.
What is h?
H, that, yeah.
This 90.
Yeah,
So
90.
that's 90. Yes.
Plus b, plus c,
C.
and close the parentheses again,
Yes.
plus c minus d.
Okay. But this is not good. Why is not? First of all, you didn't bother to simplify. I would never write 180 minus 90. I put this minus sign in and I make it simpler.
Okay.
This is one thing. Another thing is that you are using something I haven't given you.
Right.
Yes. First of all, probably which one do you mean by D here? Because there are two angles. I get confused.
Oh.
Which one do you mean by D? So you have to be careful about naming the angle. So if you want this angle, you need to name it ADC. If you want this angle, you need to name it ADH or ADB or whatever.
Okay.
So you have to be careful about that. But the point is that even if I do the simplification, that's not an acceptable formula because you have written it in terms of C and D. I ask you, I give you A, B, C.
Okay.
So it means that in your formula, I'm not saying that this is wrong, might be this equality is right, but what I expect you to understand when I write, by the way, I use this terminology a lot in terms of. So my question actually for you is to write the measure of x in terms of measures of the interior angles.
Okay.
So it means that in your formula, you need to express x on the left-hand side equals to a formula which only relates to interior angles.
Okay.
Yes, is that understandable? So let us wait a little bit more. Yes, do you have your answer?
Well, I mean, there's more than one formula, I guess. So this.
Okay, but just read it. Yeah.
Well, I mean, I think this is a solution, but I don't think it's.
No, I need your formula.
Okay.
Yes, x is equal to what?
Well, I mean, if I just write what x is, then I wrote that x is equal to the angle A minus gamma 1 and theta 1, but I need to prove to you how I found.
So what is gamma 1 here?
It's the rest of the angle A there. So
Just name it here on the
okay,
picture.
so gamma
H, A, C, or whatever.
So gamma is AHB and theta
Gamma
is
is
AHB.
AHB, so 90.
What? No.
AHB is 90.
So BAH.
BAH, so this is your gamma.
Yes, that's sorry.
This is your gamma, okay?
And is it DAC? That's my theta.
DAC, this angle,
Yes.
is your
Theta. Well, it's theta 1 in this case.
theta 1, whatever you
and
want.
the other one is gamma 1, by the way.
This one is also gamma
Yeah.
1.
See, this is a very brute force method, I think. So
No worries, I wanted your
Okay.
formula. Just read your formula.
Okay, so and then I found that well, C plus B is
No, read your formula,
my formula.
please.
Okay.
I want so because when Sami read the formula, we realized that even if this equality is true, I'm not criticizing. I don't know. Might be this equality is still true, but this is not what I want because it contains D, which I don't want. I want to have only A, B, C at most.
Okay.
Yes.
Can I just write?
So if you write your formula, which involve theta 1 and gamma 1, I don't accept
Okay,
it.
can I just write?
Yes.
my formula?
Is that understandable?
Yeah,
Because
yeah,
I want you to understand this.
Okay, I can just write it. Like the angle.
So I told you from the beginning, if you want to, I give you interior angles, all of them.
Okay.
Even though 2 of them is enough. Okay, so let me tell you something. This is a little bit the nature. I want, first of all, don't get disappointed, because that's the nature of geometry. And then I know that in high school education, more or less around the world, people doesn't care about geometry that much. They mostly focus on algebra. Okay, but this is why you are in the beginning, so you have to start thinking in a different way. Okay, But I'm just telling you that is the reason geometry, you get 2 questions in International Olympiad regarding the, so 2 out of 6 questions are geometry because they are actually hard. Okay, so I don't know. First of all, let me see how I think about the problem. First of all, I do not distract myself with a lot of letters. For example, I don't know, Oscar mentioned that, is it recording? Yes. Oscar mentioned that I call it gamma or whatever, or theta. Why should I? Because we know that this is A over 2. Yes, this is better notation. When I know that this angle, when this is angle bisector, so this one is A over 2. This is a better name, not to confuse myself. So what, this is A over 2, understandable, because I told you that this is the angle bisector. It means that this angle from here to here, and this angle from here to here are exactly the same size. And each part is A divided by 2. So, I mean, at least in a scratch paper, if you are doing calculations, I would myself rather to write A over 2, rather than writing theta or gamma or whatever. Yes? Now, still your brain doesn't have any respect for exterior angle theorem. It's a very simple one. So I consider this one, I call it D1. So D1 is an exterior angle to which triangle? Just name it, ADC. Yes? And then D is the sum of these two. And that's finished, more or less. Why? Because this is expressed in terms of A and C, but this one and this one has a nice relation. They add up to 90. So I am done. You see, I discovered the pattern, I just write it down. Was it hard? So you need to take lessons. This is not something that a teacher can teach you. Okay? You need to take a lesson from your own mistake. Why it was so simple I couldn't discover it. You need to do a little bit of thinking in your brain to make these wires, you know, make some new wires between your neurons. Okay? So here I would say that I would write D1. Of course, I am just writing it orally. If you want to, you have to write it very formally. Okay? But that is enough for our case here. So let us not spend so much time on it. So I would write D1. I'm telling you, in the exam you have to write D1 is an exterior angle for this, and this is why, this is why. I just tell you that D1 is A over 2 plus C. Everyone agrees or not? Yes or no?
Yes.
And this is good, because I have written D1 in terms of given angles, A and C. Now that this is done, this is very simple to see that this is a right angle triangle, and these two angles are acute angles in that triangle. So the sum of them should be 90. And that's it. So I know that on the other hand, x plus d1 is what? 90 degrees. I hope that you agree with me. I am done. Yes? Because instead of d1, I can write this. What happens? It becomes x plus a over 2 plus c is equal to 90. Am I right or not? And then you see the problem is solved. Because I can move these to the other sides. And I want you to tell me, do you buy my formula?
Yes.
Why is that? Why am I right here if I express this formula for you? Am I following my own words? I ask you to write a formula for x in terms of interior angles of the triangle. And this formula is expressing x in terms of these interior angles. Yes or no?
Yes.
Everyone agrees? Yes or no? Okay. But I can write it more beautiful. This is also good to know that in mathematics, I think you should also care about beauty. And beauty comes from symmetry somehow. I can write this formula algebraically more beautiful. Okay, can you do it for me? So for example, let me guide you. I have expressed x in terms of angles A and C. I want you to express it in terms of B and C. And then suddenly you see the formula is more symmetric and more beautiful. Okay, so please do that. This is algebra, not geometry anymore. This formula is an algebraic formula. I want to rewrite it in a way that x is expressed in terms of B and C rather than A and C. Okay, you should be able to do it in less than 1 minute, but I will give you 2 minutes, okay? I think you are a little bit lost. Because if you just start randomly writing relations, sometimes the problem is so hard, I myself start doing random things, you know, hoping that something pops up. But usually you should have a strategy. This question, please listen to this very carefully. This question is a very straightforward question. This relation is between A and C. I want to write it in terms of B and C. It means I have to get rid of A. Is that understandable? Yes? So this is the goal, to get rid of A in favor of B and C. There is a very nice relation between A, B, and C, which helps me to do that, and every one of you knows that, yes? But I want you to understand the strategy. Yes? I want to get rid of A in favor of B and C. So what does it mean? I just write A is equal to 180 minus B minus C, and then plug it here. Forget about the rest. What is left in my formula would be some numbers and B and C. So that is Babak's answer, yes? But you need to do some algebra to make it more beautiful and simple, yes? So please, I don't know, this is a very, very essential tool, and that is not something needs to be clever. You need to just understand what is the question. I have a relation between A and C. I want to get rid of A in favor of B and C. So you need to ask yourself, is there any relation between A, B, and C that I know so that I can use that relation to eliminate A in favor of B and C? And that relation is very famous. It's a matter of seconds, by the way. And then I put it here. So this becomes 90 degrees minus, and then, okay, I want to wait for you. Algebra, do the algebra, quickly. Yes, Rasmus, did you do that?
Yes.
What is the answer finally?
B minus C divided by 2.
Very beautiful formula, isn't it? B minus C divided by 2, yes. So let me just continue. So instead of A, I put that expression. If you want to, I can just write the details, but please try to be very fast in these things, yes? Okay. So this is my formula in principle. X is expressed in terms of B and C. But everyone, if you like mathematics, you should be really tempted to simplify this. Mm-hmm. Yes? Yes? Do you want to say something?
Or we can easily say that 90 and 180 degrees cancel out.
Yeah, exactly. So I just write 90 degrees, and then 180 divided by 2 is 90. I have a negative sign. But be careful. I divide B by C. I don't know how do you do it. There's a negative sign here, so it becomes plus B over 2. Hopefully you understand. If not, I can explain. And then this becomes plus C over 2 again. Mm-hmm. But another C at the end. Mm-hmm. And then this 90 and 90 are cancelled, but I have half of the C minus the C, mm-hmm. So it becomes C minus C over 2. And of course, we can write it as B minus C over 2. That's a very nice formula, isn't it? So if you want to find the angle, the measure of the angle between the height and the angle bisector, this angle is equal to B minus C divided by 2. Yes? Is that clear? So this is good to know at least somehow. Write it somewhere so that you can send it to your long-term memory at some point. It's good to know it. Okay? Let me try to ask you some more questions regarding this, because these things are good. So first of all, for example, you want to see is the formula sensible or not. Looking at the special cases can be extremely helpful. For example, one of the special cases is if it happens when this triangle is an isosceles triangle. For the isosceles triangle, that's the triangle whose sides are the same, these two sides of the same size, that's called isosceles, yes. So what is your prediction for an isosceles triangle for this angle? Without doing any calculations, just intuitively. The height and the angle bisector of the vertex. What is the angle between them?
Should be 0.
Should be 0. Yes? because they actually coincide. Do you agree? If I have an isosceles triangle, we will prove these things later, of course. If I draw the height, this height automatically becomes the angle bisector itself. So the angle bisector and the height overlap. And the angle between two overlapping line segments is 0. And what your formula predicts in that case, because when I have an isosceles triangle, these angles become equal. And when they are equal, the subtraction is 0, so that is prediction. So it is good to look at the special cases to make sure that we haven't done any mistakes. That's a very good tool. I want you to learn about these things. And of course, in geometry books, usually they write it like this. They put a straight line around and then 2. What does it mean? This means absolute value. So these straight lines that we put, we will study them later, of course. So this when I say absolute value of 2, absolute value of -2, it means that I am caring about the magnitude, regardless of the size of the sign. So this becomes 2. This is also 2. Yes. So this is why I have given you this one is greater than that one from the beginning, but I could say that in any triangle, prove that the angle between the bisector and the height of the same vertex follows this rule. And then, of course, I hope that you agree that this is indeed necessary, because if I don't put this absolute value, sometimes this difference becomes negative and the angle cannot be negative. Yes? Is that clear? Okay. Let me try to give you a little bit more examples here now. By the way, what happens? Let me ask you the same question. Now, very similar questions. I want you to do it faster, of course, and you will definitely do that, I'm sure. So this is ABC, a triangle. Now I draw 2 angle bisectors. One for B, one for C, and of course, this angle bisector. Yes, another angle bisector here. They go and intersect at a point. Let me call this point I. Okay? And now I am interested in this angle. Again, the same question. I want you to express this angle in terms of the interior angles of my triangle. So, but be careful. BI is one part of the angle bisector, so these 2 angles are equal. These 2 angles are also equal. And then I want to express x in terms of the interior angles of this triangle. Please try this. Okay, are you ready to read your formula for me?
Yes.
So what's that?
X equals 180 degrees minus B over 2, the angle B over 2 minus the angle C over 2.
Yes. I think that's correct. Yes, do you agree? But there is a better one.
More beautiful.
More beautiful? I don't know if, might be you say that this is symmetric, more beautiful. But for me, if the formula is simpler, I call it more beautiful.
Are you talking about that we could combine 2 divided by 2?
No,
Or
more than that.
more than that, okay.
So in principle, I only need angle A, not B and C.
Oh, okay.
So that's very nice. So if I give you this, you can calculate this. Again, under 1 minute you should be able to do it. I want you to, so this formula is correct. The people who got it, just, even if you haven't got it yet, just take it for granted and try just do algebra. This formula expresses x in terms of b and c. Yeah. I want you to write it that in a way that this x is expressed only in terms of a. And then I will come back and try to see why this formula is correct. I think there's a flaw in your formula, isn't? Are you sure about this 180? Let us see, I don't know.
Yeah, I mean, I'm pretty sure it's
It's correct, yes?
Yeah.
Yeah, there is no doubt about it. By the way, did you listen to me? Instead of giving a lot of names, it would be better probably to write this b over 2, yes? Because this is angle bisector of b. So don't give extra names because you get confused. There is nothing wrong in principle about giving different names, but then you need to have a lot of processing a lot of information in your head about different names. But if this angle is b, and then I say that this is angle bisector, it's better to call this b over 2, at least in a scratch paper. And then this one c over 2. Then immediately something reveals itself because I have one triangle IBC and I know that the sum of these three angles should be 180. And then I ask you to write a formula which expresses x in terms of the interior angles. I am done. So you see, just by this very single method, you can just save a lot of time. So you would say that x, this angle, plus b over 2, plus c over 2 is 180. And that is exactly how actually Oscar did it. By moving these two to the right, you get this. Yes? So that's correct. But let me see what we can do. Can we simplify it a little bit more? Or can we express it only in terms of a? Yes, Matthew?
X is equal to a over 2?
Not a over 2. By the way, it's not reasonable. Just, you might made a very simple, a small mistake. Do you agree that x, first of all, we haven't proven that yet, but intuitively, do you think x is larger than a or smaller than a?
Possibly.
This needs proof. I haven't shown that, but intuitively, do you think x is larger or smaller than a?
Possibly. Oh, possibly larger.
It should be what? But you are saying that x is equal to a over 2. So these are also skills that you need to learn to evaluate, to assess your solution, you know? So yes, what's your answer?
We could combine the b over 2.
No, what's your formula? Answer.
Okay, what's my formula? X is equal to 90 degrees minus a over 2.
Thank you. So that's what. So you need to be very decisive in saying things, doing algebra. Okay. So what you're saying is that, for example, I don't know what you want to do. Let me continue with this formula. So this formula is not wrong according to what I want, but I can express it more simpler. I hope that you agree with me that I can write it in this way. Is this algebra clear for you? You have to be very careful in these kinds of manipulations. Is everyone happy with this, what I have done? Mm-hmm. Yes, I have put minus sign here, but I have written b plus c over 2. And then, what is b plus c over 2? What is b plus c? Do you agree I can write 180 minus a? Mm-hmm. Instead of, because, yeah. And then I do the division again. So what happens? It becomes, that is, I think, that Matthew made this mistake. So 180 divided by 2 is 90. Yes? And then what happens? So I am a little bit confused about your, okay. So what happens here? This positive or negative, so a over 2, positive or negative, by the way? So let me write it more clearly for you. 180 minus b plus c is 180 minus a divided by 2. Yes? So I also made a mistake, Rasmus. You said that 90 minus, yes, and I confirmed that. It seems that the minus is not the correct one, yes? So this algebra, I really want you to, at this level, I shouldn't bother to explain you these details. I want you to, from now on, to be very careful. So if I want to simplify that, it becomes 180. Let me be patient. I have to put a pair of brackets, divide 90 by 2, it becomes, so it's 180 by 2, 90. Divide minus a by 2, it's this one. Yes or no? Is that understandable? Then I have to apply this minus sign in. So this becomes 180 minus 90 plus a over 2. And then this becomes 90 degrees plus a over 2. Yes or no? Mm-hmm. So that is interesting, yes? Even if you start with a very narrow triangle, this is always obtuse angle. Yes, because it is 90 plus something. And even if this A is very small, it doesn't matter. It is still larger than 90 degrees. Yes, it's more sensible now. The one I should, so for example, when Rasmus mentioned 90 minus A over 2, I should immediately detect that that is wrong. I didn't take my own lesson, you know, it's serious. So 90 minus A over 2 means that it should be less than 90 degrees. Always. Yes? It's clear that always this cannot happen. Okay, so that is the correct formula. And I would say that, okay, this is more beautiful. For me, this formula is correct. This formula is more simple. It's simpler. This is not something that I want you to memorize, but I want you to actually understand that we can calculate it. Okay, if I want to give you a very similar formula here, a problem here, I want you to also remember this notion. We have interior we have angle bisectors for interior angles. We can also have angle bisectors for exterior angles. Yes? Okay, so for example, if this is interior angle, if I extend this line, then I have this exterior angle here. This one, for example. And then I can draw angle bisector of that one. Yes? I draw the angle bisector of this one. So let me call this ABC. Okay? And then I do the same thing here. I extend this line. There is an angle here, exterior angle. I do the angle bisector here. They will go and intersect somewhere in the exterior to the triangle. So let me call this point I prime this time. Yes? And now call this one again X. So is the question clear? Be careful. I have 3 interior angle bisectors. I can also imagine 3 exterior angle bisectors. But my question again for you is that, is there any formula that you can discover expressing this angle X in terms of the interior angles of my triangle? Okay? Just do that. So we have to improve our problem solving skills. These problems follow the same logic, follow the same theorems, so you should be getting better and better when we proceed. Yes, Oscar?
Okay, so I got 180 minus A minus 2, C over 2 minus B over 2.
Okay, but can you simplify it more than that? I will wait for you.
Yeah, can I simplify it more than that?
I think
Well,
so.
I can make it.
I think there should be a very nicer relation.
Yeah, there should be.
Yes? What is the simplified version?
Is it 90 plus A over 2?
Anyone else?
Was that wrong?
Yes?
What's wrong?
C
No.
plus B divided by 2.
C plus
C plus B in brackets divided by 2.
2. First of all, it doesn't need any brackets. Yeah. No, I think Oscar's answer is correct, but are they the same or not? No, not necessarily. Yes, I think you are also correct. Is 90 plus A over 2 the same as Samir mentioned, B plus C over 2?
I think that would be the same because it's 180 minus 8.
Yeah, that's also correct.
So it's the same.
So you probably let us investigate. I don't have it in my memory.
Oh yeah, it's what.
No, again, might be you have made that's the same mistake.
Is it what?
In that
It's
case,
minus.
it becomes it becomes minus.
Yes.
Yeah. Oh, sorry. It's minus. It's minus.
Yes.
Yeah, so minus is correct because they cannot be exactly the
It's
same
minus,
formula.
sorry,
Yes.
It's minus.
Yes. Because if they are exactly the same formula, it means that always this angle top there should be exactly equal to this angle. But I don't think we have a good reason for that. Yes. Okay. So this one is 90 plus A over 2. That one becomes 90 minus a over 2. Okay, so why is that? I don't know. Which one do you prefer to do it? Can you tell me?
Me?
Yeah.
So I took, so I started a plus b, a plus c over 2.
Mhm.
Well, I mean, the first thing I wrote was 180 minus a plus c over 2 minus a plus b over 2 is x.
Yeah, it works. Yes,
Yeah.
that's correct. But if I want to give it this a name in a scratch paper,
Yeah.
what do I give this?
Um,
Because the exterior angle, the total exterior angle is 180 minus b. Do you agree with that?
Yeah.
And then I want the half of it.
so
And in my head, I divide it by 2. You see? In a scratch paper, you need to be fast, yes, to discover the pattern. So instead of giving a lot of names, I have this in my memory, but that is my goal, to write everything as much as possible in terms of the interior angles. So this angle is 90 minus b over 2. Everyone agrees with that. Is that understandable for everyone? And then you really don't need to calculate anything with scratch paper. Yes? So what do you think this will be?
90 minus 0.
90 minus c over 2. Yes? And then I have this triangle now. So this becomes x plus that angle plus that angle is 180. Yes? But 90 plus 90 is 180, and 180 are gone. I move them to the other side. So that is completely right. Yes, that's also a nice relation because that's the average between these two angles. Yes? So that is correct. But now can I express it in terms of A? If I want to compare it with that one, the answer is again yes. What I can do, instead of B plus C, I can simply write 180 minus A, and then divide it by 2. So x becomes 90 minus A over 2.
Yeah.
Yes? And then very interesting. It doesn't matter. This angle is always an acute angle. And this angle is always an obtuse angle. Yes? Regardless of the way that you draw this shape. Is that clear? Okay, so you see, one skill that I want you to learn is do not introduce a lot of letters. Try to express as much as possible everything in terms of what you want. Okay, let me go and try to do a little bit of practice about these parallel and transversal lines. Because next time I want to start a new lesson, so I just want to finalize these angles. Might be we also need to spend half a session for angles. I want to talk a little bit about angles in polygons and things like that. And then we move on. Okay, so let me just ask you a very simple question. I give you two lines parallel. Okay, I have to be a little bit careful in my drawing. Yeah, this is this line, and then I don't know, this angle and that. Okay, so I put an arrow here, an arrow here. By convention, I mean that I am telling you that these two lines are parallel, and I give you this angle to be 40 degrees, and I give you this angle to be 60 degrees, and I am asking you to find the measure of angle x here. Now, I want you to improve your skills so that you can detect parallel and transversal lines quickly. Yes? I pause the video recording and I ask you to do that for me. Yes, Oscar?
Is x 100?
Yes. What is your method?
Well, I just expanded or produced or whatever it's
Yeah,
called.
okay. So it's not that, I understand what you mean, but these are not the words that you're supposed to use. You mean you want to draw something
Yeah, I
parallel,
mean,
yes?
I just
Okay, so
I
I understand.
extended.
So your method is different from what I was thinking. Okay, just please
I
explain.
extended the line.
So this line, this one?
that one.
so you say that you produce or extend this line.
Yes, and then you find that that angle that you create there is 60 degrees.
Exactly. This angle is definitely 60 degrees. Why is that? Because you have your z here.
Yes.
Yes? And this means that this angle and that angle they are equal. And then what is this one now?
Yeah, it's 100.
Why?
Because the rest of that triangle has to be 80 since.
Don't say that.
What?
It's correct, but that is an exterior angle. Please respect that.
The
Yes,
angle is
x is an exterior angle for this triangle, so it is the sum of these two. So x is 100. So that's one way. Another way I was thinking, by the way, this is probably a better way, but let me also tell you this. So I was thinking that this is a point. I can draw one unique line parallel to this line. Of course, automatically it also becomes parallel to that one. Yes. So I draw this dotted line here. I myself draw it parallel to these two. Is it possible? Yes, because of a parallel axiom. Yes. Okay, and then I have this Z shape here. You see, this is the Z shape.
Yes.
So this is 40, this is 40. And I have this Z shape again. This is 60, so that's also 60. And the total one is 100. Is that understandable? Yes? Clear? So I drew this one parallel, and then I have two Z's involved. One Z shape, 40, 40, another Z shape in this form, 60, 60, and I'm interested in the total angle. Yes? So let me give you another one. These are simple, but I want you to train your eyes a little bit. So let me draw something. This line I have, and I have this line. They are parallel. And then I have this. Of course, my figure is not probably into scale. Don't bother about that. Yes, so I give you this is 30, and I give you this is 60, and I give you this is 90, and I give you this is 70. And I ask you what is x. Of course, my picture is really, really poor. It's not precise at all. It seems that these two angles are exactly the same size, but forget about those errors. Okay, so what is your method? You more or less did the same thing as you did in the previous one? Okay, so that probably works because I think your answer is correct.
Yeah.
But let me also follow this method again.
Yeah. No, wait, I use that method.
Ah, you use this one?
I use that.
Okay, so what you do, actually, probably you draw three parallel lines.
Yeah.
Yes? One from here. One from here. And one from here. Yes? And this is possible. And then you need to think about Z shapes, yes? So, what is this angle?
30.
It is 30. They are corresponding angles here. There is no Z shape involved. Then what is left over?
30.
30. And then you have this Z shape. Yes? So this is 30 again. And then what do I need to do? I need to find the other part. But I need to look here now, yes? If this is 70, what is this angle?
That's 20. No,
What is this one?
no,
It's also 70.
it's 70. 70.
Yes? And then what is left over
It's 20.
is 20. And then what is this one?
20.
20. And then the whole one is 50. Is that understandable? So I mean, these are not hard. You need to sit down and convince yourself that this works. Is that clear? Okay. Let me give you one more and then make it a little bit more interesting. I can draw it here. So again, I have this line parallel here. I don't know. This is 50, and then I have this line again parallel to that, and then I separate 20 degrees from here, and then I draw another line parallel. And then this is my angle that I wanted to calculate. So these three rays are parallel with the information given, and with my poor picture, I'm supposed to find this x. Yeah, just wait, Oscar, a little bit. Yes, Sami?
No, I calculated the answer.
You didn't calculate.
No, I did calculate.
So what's the number at the end?
150 degrees.
150. Well, yes. Yeah. So so I don't know. Let us do one way. You might find another way yourself. That's up to you. But for example, if I extend this, so then what happens here? So I want to know this angle. If I call this angle alpha, I hope that you agree with me. This angle is also alpha. Yes or no? Why is that? Because these two lines are parallel. What is the name between these two angles? If you remember, they are corresponding angles. That was an axiom. So if this is alpha, which I don't know yet, this is also alpha. But I know the total angle. Why? Because that's my z. Yes? So if this is 50, the total angle should also be 50. And if this angle is 50, what is left for alpha is 30. And if alpha is 30, this alpha is also 30, so this one is 180 minus 30, which as you said is 150. Yes, is that clear? Okay, but let me now, before the lesson ends, okay, let us just do this one now. Oops. What I do, I want you to think about this problem now. I have two parallel lines, so let me just do that like this. So I have one line here, and let me just break it into something like that. These two lines are parallel, and let me call this angle A, B, C. I want you to calculate A plus B plus C. By little a here, I mean the measure of the angles. So you see, I was not careful about how to draw. I have to be careful only to draw these two parallel. But what is the length, what is the inclination? I didn't worry about those at all. Is it possible to give a straight number for this, regardless of the details of my shape? Yeah, when I see it from this angle, it's a little bit poor. So they should be parallel. Yeah, I don't know, even it's not very good, but just wait. Okay, because I want to continue the lesson a little bit. So, do you have any answers? Rasmus, do you have it? What's the answer?
Should be equal to 360 degrees.
Yes,
Is it 360?
that's what I found.
Yes. It's 360 degrees. Yes, that's correct. Yes? I want to hear from you. How did you do that? Is there any line that I need to add or something? Then I can do the rest. So I don't know what is your method.
Could add a parallel line going through
This one, you
the
mean?
B point.
Yeah. So what you say is that you draw a parallel line here.
Yeah.
Okay, and then what happens?
We can say that then we
So you can say something like that. If I ask you what is this angle, can you answer that?
A.
That's A. That is a very stretched Z. Yes. So if this angle is A, that angle is also A.
Then we have another.
And then what?
Then we have another Z.
But by the way, this is also C, isn't it? Because now that's another Z in that way. And then what I'm asking you is A plus B plus C, and A plus B plus C is actually this angle. And that's 360 degrees. Yes? That's true. But let me try to think a little bit deeper. I want you to understand these things. In principle, you should be able to guess that this is the correct answer. How? It's intuitive, but I want you to learn these things. Can I see this shape as a quadrilateral?
No.
Can I see this as a quadrilateral?
It's a quadrilateral.
You know, quadrilateral is a shape with 4 sides.
Oh, okay.
But can I see that intuitively? Can I see it in that way?
I guess.
I guess, what do you mean by I guess?
Well, I mean, it could be a quadrilateral that just... Well, what I did, I just thought of it as a pentagon.
It's not a pentagon.
No, but if I just drew a straight line down, and then I could just figure out it was 360.
No, let me tell let me tell you something. I want to keep it a quadrilateral. I want you to try to imagine this as a quadrilateral. Of course, this is not a quadrilateral.
Yeah.
Yes, but in principle, I don't know. Have you heard about these 2 parallel lines will not intersect unless? Have you heard about it? They intersect where? Yes?
At infinity.
At infinity, okay? That's a good, by the way, it's a good idea. So it means that these lines are parallel, but they will go and intersect at the infinity, okay? So, I don't know these angles, but I can intuitively feel, I'm not saying that this is pure reasoning, but what would be the angle which is there at the very, very far end?
0.
Should be 0. And then I have a quadrilateral that I have 3 angles, and then one of them is 0. But the total interior angles should add up to 360 degrees. There is nothing left for the 4th one. So this becomes A plus B plus C plus 0, which is a little bit strange, should be 360 degrees. And then A plus B plus C is also 360 degrees. It's not very, by the way, very bad. Because assume that I have some deviations, you know, it will go on and they will intersect somewhere here. This angle is very close to 0. It's not 0, but this one is a quadrilateral. It's a real quadrilateral. But this angle theta is very close to 0, if you want to. Then it means that A plus B plus C is very close to 360 degrees.
Okay.
But even if I extend it more, if my deviation is less, this approximation gets better and better. I'm not telling you that is the reason, but I am telling you that is somehow of guiding you towards that. For example, let us see if this works or not. Let us think about it. So, can you predict what will happen here? I will have a line here, but this time I break it into more parts. 1, 2, 3, and then parallel. And then I call this one A, B, C, D, and now I ask you this question. In Olympiad problems, these are good skills to learn because it gives you some idea. This is not precise reasoning, of course, but this gives you some idea about guessing the number if you need, and then go for it. Yes? So, okay, I want to hear from you again. I think that this becomes very simple now. To guess at least what the answer is. I have 1, 2, 3, 4, and 5. So you can view it as a pentagon. And then it means that we already know what is the sum of the internal angles of the pentagon. What is that? Do you remember the formula? Formulas are very important. What's that? Times n minus 2. N is the number of sides. So if I have a pentagon, what happens? This becomes 5 minus 2 multiplied by 180, and that is 3 times that. So that is your guess. So this means that if you want to do it really fast and surprise people, I hope that you agree that this should be 540. That is an educated guess, not just a random guess. And then you can go for it. Okay, so let us see, is it really 540 or not? I want to add these angles up, and I was not careful at all. I was only careful about drawing these lines parallel. And then I want to see if that A plus B plus C plus D is really 540 or not. Okay, so since the time is running out, please just tell me, Oscar. So what is your method?
Well, I mean, I just did the same with drawing parallel.
Okay, so let me just do it. Please, I want to have your attention, please. Okay, so you say that I draw a line parallel here. Then this would be a little bit problematic, I think. Not problematic, that's correct. But you draw this line parallel. You want to draw another one here?
Yeah, that's right.
Okay. It's not exactly like that. It's not so nice. You need to do a lot of work. Yes? So what is that?
Well, I mean, D is... Like,
So here, if I continue these lines in my head, so what do you want to say?
well,
So you can say that this is A.
Yeah, that's it.
Okay. Then, can I say that this is C? Unfortunately not. Because this is D and this is also D.
Yeah.
Yes? Okay, so then what happens?
That's D.
Wait. No.
That one there is...
Okay, I don't want to go for it, but at least I want you to understand this is not as straightforward as before.
No.
It is definitely will work. If you are patient, sit down, do the work, it will work. Yes? But at least I want you to see it's not as straightforward as this one.
No, wait, that's not D. Shouldn't D be on the underside?
Yeah, sorry, that's not D. You're right. This one is D, so this one is D.
That was D.
Yeah, thank you very much for correcting.
You can put C right there, actually.
What?
You said you couldn't put C there, but you can.
No, C here. C is from here to
Yeah,
here.
exactly. So C can be between A and B on the other side.
No, but so I just
Oh, no,
want
no,
you to, because we don't have time, I just want to finalize this lesson.
Yeah.
I want you to see that I am not saying that this method will not work. It will work if you are patient and sit down and do it properly. But this was very straightforward in that case. This is not very straightforward. First of all, my question is that can you find a different way that it will work for all possible cases, even if I break it into more pieces?
Okay.
Yes? So you see, I want you to see that this method will work, but if I can find a method that will cover all these things, definitely that method is superior to this. Is that understandable? Because I have to be very careful about the details when I increase the number of these. Yes, Buel?
If you draw a line
From where to where?
from the two parallel
Yes,
lines.
to here. Yes?
Yes, the two parallel lines, and then you get
No, from where to where? From here to where?
a straight line.
A straight line means because when you say straight line, I might think in this way, I might think in that way, I might think in that way. Just any straight line.
Yes, so that it creates 19.
No, okay. So you mean this something like this here or
Yes.
from here?
It doesn't matter.
Okay, it doesn't matter. Okay, I wait for you. Yes.
And then you get a shape.
So you say that I draw a perpendicular line to
Yes,
this.
a
We learn that this
perpendicular
become automatically perpendicular to that one as well. Then.
Yes, and then you get a shape with how many?
Very
sides.
nice. I didn't know about that, but I will go for it. Yes, that's better.
Yes.
Because
and-
now what you have one side, 2, 3, 4, 5, and 6.
Yes.
And you already know what is the internal angles, the sum of the internal angles, and I have two angles 90, so I can find the rest.
Yes.
It's very good. Thank you very much. So you have to be careful. You cannot say just a straight line. You have to say the straight line perpendicular to that one. Just let me finalize that. So this angle is A, this angle is B. So forget about these dotted lines. Yes. And then what we say is that the sum of these A plus B plus C plus D plus another 90 here, a 90 here, another 90 here, is the sum of the interior angles of a hexagon. Yes, 1, 2, 3, 4, 5, 6. And then we know that the formula is there. If I put n equals to 6 here, what will happen? It becomes 4 times 180, which is 720. Yes?
Yes.
And then this is 180, remove it, it becomes 540 as we guessed. So that was a very nice way to guess the angle. Yes, is that right?
Yeah.
Okay.
But I did that on the first one, and that's I figured out. But is that can you? Yeah. And another thing about it is you can use axioms to prove this. Right? This isn't intuitive, like this method.
For this one?
Yeah. No, the one Oral just mentioned.
Yes.
It's not intuitive, right? Like this isn't this is an actual proof. You can use this.
This is an actual proof, I think.
Yeah. Okay.
You can say that I can draw, I don't know, if you want to be very precise, you say that I choose one point here and draw a perpendicular line.
Well, it doesn't really matter what line you draw because it's
Yeah, it doesn't matter.
Yeah.
But you need to say something. I mean that if you want to see that this is really, really a proof.
Yes.
Yes, based on the axioms that we have. So you see, which method is superior? Do I need to be worried about, can you see immediately that this method that we will mention can be immediately extended to more breaks, yes? It doesn't matter. So this is superior, but it was a little bit confusing in the other way. Is that understandable? Okay. Yes, so this I want you to know, so that idea that you can have an educated guess is a take-home lesson from this one. So you can look at the special cases to guess the number that you want to do and then continue. Thank you very much. Yeah, we have to stop here because people have lessons. Questions? Thank you.